Thanks. That was a great introduction. Thanks. I almost have nothing more to say, I think, after that. So first thing first, feedback and questions. You're probably familiar with this after 3 days of conference. On that website, with that code, you can have all your questions. And please bomb me with feedback, because this is the first time I'm presenting this talk, and I'm really interested in any kind of feedback. Maybe later when you see me outside, cry and bring me some chocolate or something. So, some things about me, fun facts. I come from Italy, but I'm based in the Netherlands. And I once actually cycled all the way from Amsterdam to Rome, which is my hometown. It took me about 2 months. Another fun fact, I used to have a side business selling food on the street, Italian food on the street. If you want to try to have a food business, I can highly discourage you to do that. So you can ask me after why. But maybe more closer to software development, I am also a big community guy. So I founded and ran the Reactive Amsterdam meetup. We're 2,000 community strong members, talking about everything reactive, from reactive programming to reactive design. But also lately I am a conference organizer as well. We organized the Kubernetes Community Days Amsterdam about 3 weeks ago, and it was a great experience. So to me, actually, community engagement really is the most fun part about software development. But there are also, as you probably know, some frustrations. And some of them that really frustrates me deeply are, for instance, when projects don't get allocated enough time, not getting time to improve the brittle things because it just works fine. Does it resonate with anybody? No? Yes. Yeah, I thought so. Project owners disregarding the ubiquitous language from domain-driven design, because for what business is concerned, you might as well call it Joe. I've heard this literally. Or working at in a product-oriented company where tech is really just a cost to get their business going, only seeing a little bit of tiny slice of the project. Maybe you would like to have a broader understanding and broader view, and many more. Software can be frustrating, and I think we all know that. But side projects to the rescue. Oh, I went too far. So I love side projects. Side projects are what let us learn exactly what we want. They are our little world. We decide everything within that little world. It recharges our battery. At least it does it with mine. It's a party. I really love side projects. And so this talk today is really the story of one of my side projects. Has anybody invested or traded cryptocurrencies? One hand, 2, 3. Okay. So we got someone familiar with this website. I'm sure you recognized it. This is CoinMarketCap. It's a website that gives cryptocurrency values and market capitalization at all times. These are just the two most important ones, Bitcoin and Ethereum. You can trade cryptocurrencies just like you trade apples and pears. And this website tells you, this has APIs, how the market is going, up and down, and all that sorts of data. And someone had the idea of creating a website called CoinMarketCal for calendar, making it extremely confusing if you want to sort of name the two differently or something. And in this website, CoinMarketCal, you get to see events related to cryptocurrencies. So it will tell you, oh, there is a conference about Bitcoin on this day in this city. Or it will tell you in 3 months, there is a new release, a new product. There is, or maybe another event is a fork. There's many different kinds of events. So then I thought, maybe, just maybe, there's a pattern between these things. Cryptocurrencies are notoriously chaotic, and it's really impossible to predict where it's going. And so I thought, maybe if I can dig enough data, I can find some patterns. How about I find a way to correlate a cryptocurrency, one event related to it, and a price fluctuations? We could, do some interesting gains, I think, with this kind of knowledge. So I set out to do this. The goal of the project then is something like this. We would like, at the end, to have a function that taking a cryptocurrency and a event category, such as a conference or a release or whatever, gives us some price variation within some confidence. It's a pretty basic, but it's a start. So for example, we would like to know that if there is a conference about Ethereum, we can expect that after the event or on that day, Ethereum price will jump up 10% with a 90% confidence. It feels a little bit like, Back to the Future when the guy goes back with the horse race records to do a bet. But I think it's something could be worth investigating. So I named this side project Caterina because my niece was just born at that time, and I set out to use reactive architectures and reactive principles. But also it's a data project, and I was quite dry about data back then, so I bought that book from Manning, The Art of Data Usability. It's a pretty cool book, but unfortunately it got cancelled. I don't know why, but in fact I had it almost complete. But, well, if you want a copy, I still have one. Let's not say it too loud. But anyway, in fact I blogged about this project quite extensively, and there's a link down there that has the more extensive writing about this talk. So let's dive into it, starting with data aspects. Something I learned from that book is that when you're doing a data project, trying to data mine and get to some decision-making process, you're really trying to climb the pyramid of wisdom, where at the bottom we have raw data, just data we collect, that then becomes information, which is ordered, processed data, from which we can extract knowledge, once we identify patterns there. And on top of that, wisdom is what makes us able to make decisions based on those data. In my project, this would be, raw data would be crypto events and the price variation around that event. If I filter, format, clean that data, then we get information from it. Knowledge would be price patterns as a result of an event. And then wisdom would be to make reliable prediction. What I also read in that book, there's many phases in a data engineering process. You don't really need to read all this, but you start with the design, collection, management, processing, and so forth, and every area has questions that come with it. So what I'm really trying to stress here is how important it is, which I really learned, to prepare things in advance. I totally used to be the kind of guy that jumps in and hacks stuff together, but I think maybe aging, I don't know, it's growing up. Thinking about these things in advance is a big plus. It's a big advantage for later. So in fact, if you take all these areas and start asking questions about, for instance, how are you going to manage your data? Or at the end, what happens when I stop working on this project? Each area has questions, and then you start to answer it, and then you come to something like this. I really did all this job. I know the font is super small. You're not supposed to be able to read this. It's just to show you I've done my homework. And then when you answered all these questions, well, then you have a solid base to start. So this was for the data part of the talk. How about reactiveness? Now we're going to slowly working towards implementation phase. We start with event storming. Has anybody done event storming in your daily job? Oh yeah, good, lots of people. So this is a bit of a simplified version, but in general, we can start by dividing the screen into sort of input that come from the outside world, and then internal, that's our little internal world where we have control over, and output. What is our system going to tell us at the end? And in my case, I want to check every day the API of that coin market calendar website to see if there's new events being announced and when they are. So my trigger will be a simple event, a new day has come. Now, events usually trigger commands because you want to react to an event, but based on policies. So what you see there in pink is a policy. So when this event happens, what do I do? And then if a new day has come, I want to poll the API, see if new events have been announced. Now, each policy then results in a command, which in our case is indeed poll the event API. Someone will take care of doing this. And guess what? Probably a command will do some work and result in more events. So in this case, lots of stuff can happen. Maybe there's a new event has been announced, and maybe the event is in 3 months, but maybe the event just started today. It is actually today. Or maybe the polling failed, and so on and so forth. So each command will generate, you will have to deal with every event that comes from the command and react in a different way. And if you keep going like this, then you can, again, new commands, and in the end, you will have a full picture of what your system should do and react to anything possible. Of course, you do this at the beginning, but you also learn things along the way, so you go back and change it. It's, of course, an iterative process. But so probably the most important lane is the one at the top. What I want to do once I have enough data is I want to train some machine learning model, because maybe there's some patterns that we cannot see, but some sort of AI can see. So at the top, you'll have something. If there is a new event announced, I train my model with the new data every day that I accumulated, and then I evaluate this model. And this model that I evaluate constantly is then ready here. So when a crypto event has been announced, like, there's going to be a fork of Bitcoin on that day, well, then maybe this model can tell me a forecast about the price of Bitcoin corresponding to that event. And then, so as you can see, then at the end, I need some way that this will be published. So maybe I'll receive a Telegram message from a bot or something. And the final step about event storming, the way it links to your actual software implementation, is that with some yellow stickies, we can actually delegate all these tasks to someone. So crypto event or coin, these are aggregates in DDD terms. And so one aggregate usually encompasses 2 of these. It's the guy that receives a command, does something with it, and then emits an event for further processing. Aggregates are usually finite state machines, like Lagom, for instance, like the talk before from Renato. In Lagom, they really are state machines. And so, here you are. You have a picture of what your system will want to do. Now, before we move to the next slide, for instance, you can see that there's a crypto events aggregate here and a coin aggregate here. This will be responsible, one for polling the event API, one to poll the price API and collect it. And you see that this coin guy also appears here and other places. So it does multiple things. And now, once you have that, then you can move on to some real bounded context definition. So this is the way I've done it. It's not written in stone. It could have been done differently, and it probably there's many different ways. They all work. One is better, one is not. But what I decided is I put 2 of these aggregates in one single bounded context, which will then be a service. And then you define the persistence if you need it, and you define how the services interact with each other, so they're APIs. In this case, really is an event bus. And what I got down to is a crypto service that checks event prices and coins and coin prices from these external APIs, and a prediction service later that gathers all this data and will, tell us how to get rich, really. Each service has their own data store. We got this one. I choose Google Data Store, GCD. Oh, that's a mistake. Google Data Store. Here I got BigQuery for the prices, because it's probably going to be a lot, and I want to be querying them in different ways, and so forth. Now, if we then focus on this service here, and we sort of expand on it, it's a service that contains 2 aggregates: crypto event, coin aggregate, like from Event-storming earlier, and then plus configuration and common services and things like that. And then each aggregate will have its own way of communicating with the rest. So in reality, maybe aggregate is not even the perfect term here, because they're not really stateful. There is some state in them, like authentication tokens and things like that. But it's not like a cart on Amazon that receives orders from users. And so, but anyway, aggregate. We call them aggregate this time. And now we're going one level deeper in abstraction. And so we're going to look at that actor right there. What's going to happen in there? Well, if you consider what it should do, it really is mappable to a pretty linear flow. So when a new day has come, and then we know that, well, this is a bit technical, but when the new day has come, we want to trigger this flow that will check the events for us. And then once we have marshaled and parsed the result of the event API, we will pack it the way we want and publish it on the pub sub, the event bus thing. I chose Google pub sub, could have been RabbitMQ or anything. And then, after this event has been published here, we can tell to the coin actor, which is actually part of the coin aggregate, that will start monitoring the prices of this coin. Now, this event request flow, and this is really the power of Akka Streams that we're getting to. Of course, this event request flow is very complicated in it, because it needs to poll our API if we are authenticated. If we're not, we need to get a token first. And then we need to prepare a request, submit this request. This request can obviously fail. If it's a success, though, then we look at the content of the response, and it might be that it's a success, in this case, happy flow, but it could be a failure. Or we could be unauthorized right there. And so, again, if we are unauthorized, we need to start the flow to request a token. And that flow on itself can be problematic. There you go. Same story. Request a token, parse the request. In the end, we're doing a similar thing. But then I think the power of Akka Streams is that from this high level of abstraction of having these sort of coarse blocks, we can get down to literally, detailed blocks that tell us what's going on really concretely. And this is easily mappable in code. So there's not much code in this talk. There's pretty much 2 slides about it, really. This is the first. So here we're mapping the very, very top level flow. And as you can see, it's not very big. It's maybe 8 lines. Where this is the tick that basically once a day will emit a check event trigger. Here, we pass it down to the event request flow, which we have just looked at. And then these results we unmarshal, we transform it into our own event, our own API, our own objects. We publish it, and then we tell it to the coin actor, so the coin actor can start monitoring the prices of a coin around the time of that event. If we want to implement this event request flow, which it's a little more complicated because there were like cycles in it and merge operations, or things are fan out or maybe fan in or things like that, then this one. Then Akka Streams also provide us a graph DSL language where we can basically, the power of this graph DSL, so we're going from this to the actual implementation, is that it really helps us map each block to something using this weird tilde arrow character. And if you look at this code, it really sort of looks like the blocks that they are communicating with each other. So there you go. Inside this flow, of course, all these blocks are implemented separately. We're just going to look at that request filter right at the end, where it's basically a partitioning thing. It's a partitioning block where you get an HTTP response in, and then you look at the status code in our case, and then this function, if it's OK, then it maps it to port 0. There it is. If we are unauthorized, it's going to be sent along the path 1. Anything else will be an error, and it goes up here. And these numbers here, 0, 1, 2, you just saw them in the previous bit of code here. So the request filter out, if it's 1, yeah, we're going to the auth request flow. If it's 2, it was just a generic error, we're going to the error sync. And so there you go. It's really, for me at least, it really makes it really easy to map real business logic to implementation. Really, if you haven't ever used Akka Streams, give it a look. God bless Akka Streams for me. Well, so what we have done for the reactiveness part is we started from this event storming, modeling our domain. Then we went into deciding what the bundle contexts are and their APIs and how they work. And then we expanded into one single service, looked at the aggregates in there, and then looked at business logic that happens within one actor, and finally got to the code. This is the process we have followed. And I think this is really, for reactive architectures, is a really good pattern to follow. Right. You know, every project is different, but this line, these instructions here in this order are very, very powerful. Also, something else we have learned, I'll repeat it again, reactive systems and designing them is not jumping straight into hacking. I think I've learned this the hard way, and maybe maybe you disagree. But for me, I think this kind of planning and this sort of going from a high level of abstraction to details is really crucial. Well, really quick, cloudization. I'm not going to say much about this, but we all are cloud natives, right? So we like to put stuff in Docker and then run it on Kubernetes and on your vendor of choice. I'm not endorsing Google Cloud with respect to Amazon and the other ones, but I really kind of am because I kind of like it, and I really like Google services rather than the other ones. But then, you know, as you of course know, once you put stuff in Docker and Kubernetes, you can run it pretty much everywhere. In fact, I did some previous talks about Akka and Kubernetes, and I did a webinar with Lightbend, which is on YouTube right there, and there's some code on GitHub as well. So that's pretty much all I'm going to say about the cloud and running our services, except, this is something I want to share with you. Yeah, this was the monthly invoice from Google, and I like that it's transparent. I mean, I've run, you know, most of the companies I've worked with in the past had Amazon because it's the number one and all of that, but the costs were super obscure. I mean, I hope did they improve? Is it a bit better now if you're working with Amazon? Anyway, I think Google's really clear, and so I was paying about 17 euros a month to run these things. And I think now we're getting to the part that you're all waiting for. Now we collected all this data. Are we going to get rich? Are we going to get Lambos? Well, the first thing, the first time I looked at this project, I let these services run. And I looked at it for the first time only after 2 months. Big mistake, because I realized that something was going wrong. For instance, the events API, so in this case there was an event about this coin called Yoda, a coin about Internet of Things. And the symbol that comes with it was Mioda. That's the ticker on the market, let's say. But then the rates API, the price API, was using Yoda without the M to identify it. And so I missed 2 months of measurements because of this. Super sad. So another learning here is don't forget about things so easily, but check it a bit more regularly than what I did. But in the end, I was able to observe things for 6 months, observed about 2,000 events in 20 categories of events, about 500 different cryptocurrencies. You wouldn't know how there's so many out there. And I collected about 500,000 price measurements before and after each event. So I mean, I don't know about you, but I was quite scared when I first sort of looked at that table you're seeing in the background. And I'm like, what do I do now? So I said, okay, let's start with something simple. This is an example from a coin called Eternity, about a release event that took place on the 26th of November 2018. And this is the variation across the event. So this is the line where the event is happening. Now, yeah, again, I'm not a real data scientist, so how do I take it from here? One first measurement that comes to mind is the average. Is the average price here higher or lower than the average price here? Well, in this case, those are the average, and in this case, it was actually higher before the event. But so, by doing this over all the measurements I've taken, it turns out that, see, except the blue part, all the rest showed us that the average price over that 2 days after the event is higher than the average price on the 2 days before the event. Maybe we're getting somewhere. If, for instance, we take another example of another event, this is about the coin called Ethereum. On the 1st of November 2018, there was a conference about it, and this is how the price varies. And the average after is clearly higher. And you might say, okay, is this all I need to know? Well, probably not. This really doesn't tell us much, in fact. We are still able to do major damage. For instance, ideally, you would like to buy there and sell here. Amazing. Fantastic gain. But it could also go wrong. So you don't want to buy here and sell there. So the average really is not telling us much. And then I've been doing lots of exercises with variance and standard deviations, and I don't have time to go over it now. But please, if you are a data science, please help me, because we might be onto something. But well, so how do I go on from this? Well, what I did is kind of very basically looked at these other measurements that I found out by myself. I introduced the spread measurement, which is, let's say, the maximum loss that I could have here is, I don't know, I can lose 20 euros if I buy the worst and sell at the worst combination. And this is the maximum gain. So if I buy at the right moment and sell at the right moment, this is what I can have. And also the spread is this sort of distance, this length. And in it, what's its positiveness? So how much of this spread is actually on the grain side of 0? And so in this case, minus 20, 40, spread is 60, and positiveness is 2/3. Right, so if I map that across all the events that I collected, well, I see that the spread stays kind of not too high in general, but that doesn't matter in fact. But the positiveness, well, this is where things are not so maybe promising anymore. It really has a bit of a normal distribution, which really tells us that it seems that crypto events don't affect their prices that much. If we could make this first guess. But there's still, as you can see, there's still a bunch of things here. So where positiveness is really high. And if positiveness is really high, it means that if we buy before the event and the average, so if positiveness is high, it means that we have a lower risk of losing money. Basically, that's the idea. So I went and say, okay, what if I can find some couples of coins and event categories that sort of reproduce this a little predictably. So there we go. I applied this filter. I want to look at all the data I collected and find all the data of the events that have positiveness greater than 85%, where it's related to a category that appears at least 5 times, of a coin that appears at least 5 times in my data set, because there's many coins are just not much going on. And well, this boiled it down to 31 events. Not many. But still, if I then, okay, not losing hope, I try and apply this, all these three categories, all the three criteria at the same time. Well, we're down to really one coin, and to this event, community event. One single coin, ladies and gentlemen. Are you ready to see what that is? It's Holochain. That O is their symbol. It's kind of unsettling and a bit scary to me. Their symbol, well, it's a blockchain written in Rust. They describe it as BitTorrent plus Git plus digital signature. Good luck in understanding what that means. Their symbol on the market is HOT, appropriately. It started trading in May 2018, and actually last week I checked and it ranked number 44 in market capitalization. Not too bad. Their all-time high price was $25 million. But nonetheless, we got this. So it's kind of promising. Maybe we're getting somewhere. However, I looked then at all the events about Holochain, and only 5 of them, 5 out of 10 community events about this coin gave me such promising results. And in fact, these events are not even world-shattering, really. They are meetups around the world. There was one hackathon in Amsterdam. Too bad I didn't go. There was the Switzerland meetup, think outside the blocks. I mean, they're creative, these guys. And they're sort of all over the world, which is kind of nice. But all of this tells us that these results are likely coincidental. So, conclusions. I learned a lot of this. In fact, I can't really confirm nor deny that there's a link between events and price fluctuations. I really can't, and mostly because I don't have enough data. 500,000 measurements, all those numbers, they, to the untrained, eye like mine, they seem quite high, but they're not really. But the real problem here is that the data set grows too slowly. I mean, let's say a very popular cryptocurrency like Bitcoin, the most popular one. There's maybe, I don't know, 20 events per year. That's not a lot. I mean, even if it's 50, which it isn't, it's really not a lot to try and extract patterns. Especially in this crypto world, which is as chaotic as you can imagine. It's, I don't know, it's just a super mess. So, well, I don't think I have any conclusive evidence one way or another. But it was a lot of fun doing this. And my personal takeaways is that really reactive patterns and tools, this sort of cascade we've seen before, is really powerful, even for small projects. Sometimes I hear, at my meetup, but I don't need this. I'm not PayPal. I'm not managing, a billion transactions per second. Well, to me, that doesn't matter. I think these tools and principles are really important and really useful in any case. Then, yeah, of course, value of planning things before hacking things together. Try it. If you have never tried it, it's very beneficial. You'll thank yourself later. Data is never too much, and data analysis is hard, and it takes a long time. And yeah, while collecting data, keep an eye on it. The temptation was, very, very strong to abandon it and sort of, this thing I've done is so resilient and so robust, and just walk on your own legs, son. But in the end, I should have checked it earlier. And probably, the best, I think, inspiring thing that comes out of this side project is that really curiosity is the stepping stone of knowledge. Maybe I didn't get anywhere, but maybe some of you would have. So I would say really keep starting your side projects. It is actually possible to finish them and get somewhere. I have here a slide with all the references that I've used during this talk. Oh, I forgot to mention this. It's a great event modeling tool. Instead of doing the the stickies on the wall. There's a guy in this room who's very expert about how you peel stickies from the block. This thing makes it digital. It's a really cool tool. And that's all I had for you. Thank you very much for your attention. Do we have time for questions? If there's any.
Yeah, we have plenty of time, I think, like 4 or 5 minutes.
Wow.
So just.
So there it is. Oh, there's a few. Let's see if I can bring it on. Oh, it went black. Oh, there he is. Come on, Chrome, be good. Okay, so where should we start? Can I get that book? No, of course you can't. Come later. Did I get rich and just try and get rid of competition? I wish. No, I didn't. Have you ever used any ML model for predictions? Yeah, that's a very good question. So the data set is still there. I switched off all the other services, but the BigQuery data set is still there, and actually cost me 4 euro cents a month. But it is still there, so we could still run some. I haven't, because in the end, after all my manual analysis, I was a bit. I lost a little hope, but we could. Did hypothesis work? With our quality of predictions? Well, none, because I did no predictions in the end. It really seems to me that it's a bit random and noisy data, but maybe actually I should use machine learning. Did take possible cross-currency impacts into account in your model? That's a very good question. So all my rates were against the euro or fiat, but not cross-currency. That sounds like it would be a lot of data collection. But well, whoever asked this question, if you become a millionaire, please remember my GitHub. My Twitter account was right there on every slide, and I think these slides will be available later. I think that's all for questions. So, well, thank you guys very much. Again, enjoy your lunch.